This tutorial is for 4th grade, Module 5, Lesson 4. The directions say the total length of each tape diagram represents 1. Decompose the shaded unit fractions as the sum of smaller unit fractions in at least 2 different ways. Well, to start with, we're going to look at this fraction. We have a whole, and it's been divided into 2 equal pieces. And each of those pieces represent 1/2. One piece has been shaded. So this shaded portion of the tape diagram is showing 1/2. That 1/2 was divided into 2 pieces. Each of those pieces represents 1/4, because compared to the whole tape diagram, it would take 4 of these pieces to create the whole. So 1/2 can be divided into 1/4 plus 1/4. In the next diagram, again, we start off with 1/2. 1/2 of the entire tape has been shaded. That piece was broken into 4 pieces, but each of these pieces represents 1/8, because it takes 8 of these pieces to make the whole. So this tape shows that 1/2 can be broken into 1/8 plus 1/8 plus 1/8 plus 1/8. We call those equivalent fractions. In the next question, we can see that the shaded portion has been broken into thirds. There are 3 of these pieces that make up the whole. So they are thirds. One piece has been shaded, so that's how I get 1/3. We divided that third into 2 equal pieces. Well, each piece has to be 1/6, because it takes 6 of those pieces to make the whole. That means that 1/3 is equal to 1/6 plus 1/6. Over here, I start with a third again. It takes 3 of these pieces to make the whole. I have 1 shaded in, so that's how I get my 1/3. Now this piece has been broken into 4 equal pieces. That means each of these pieces is 1/12, because it takes 12 of them to create the whole. So I have 1/12, 1/12, 1/12, and 1/12, which means 1/3 is also equal to 1/12 plus 1/12 plus 1/12 plus 1/12. We're going to create our own equivalent fractions in the next section. Well, first we need to determine the shaded fraction. Here's my whole, and I have 1 piece shaded. It's 1 piece out of the 4 that make up the whole, so that's 1/4. I can start by dividing each of those pieces in 2. Now I have 2 pieces that make the shaded part, and each of those is 1/8. That tells me that 1/4 is equal to 1/8 plus 1/8. Over here, I also start with 1/4. This time I'm going to divide each piece into 3 sections. That means that each piece has to be 1/12. There are 12 pieces in all that make up the whole, and then 3 of those pieces are shaded, which tells me that 1/4 is equal to 1/12 plus 1/12 plus 1/12. Let's look at one more example. This time I'm starting with 2/3. There are 3 pieces that make the whole, 2 are shaded, so that's 2/3. I'm going to divide each of those in half, and each of these sections is 1/6, because it takes 6 to make the whole. Now I have 4 pieces that are shaded. 2/3 then is the same as 1/6 plus 1/6 plus 1/6 plus 1/6. Over here I'll start with 2/3 again. This time I'm going to divide them into 3 pieces each. Now each piece represents 1/9. There are 9 pieces that make the whole. 2/3 is the same as 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9, or 6 groups of 1/9. In the last section, we need to draw tape diagrams to prove that we have equivalent fractions. I started by drawing the fraction 2/6 on a tape diagram. I drew a hole, broke the tape into 6 equal pieces, and I shaded in 2 of those. So this represents 2/6. Now I have to show that it's equal to 4/12. If I'm going to change 6 into 12ths, that means I will divide each piece in 2. That gives me 12 pieces for the whole, and you can see that 4 out of the 12 pieces are shaded, which makes this statement true. 2/6 is equal to 4/12. And in my last problem, I need to prove that 3/4 is equal to 6/8. I've drawn a tape, I split it into 4 equal pieces, and I shaded in 3 to show 3/4. If I want to go from 4ths to 8ths, I need to divide each of these in 2. That will give me 8 pieces that make up the whole. You can see then that 6 out of the 8 pieces are shaded. That proves that 3/4 is equal to 6/8.